people who aren't.
Okay, recording now. We just got done with section 9.1. Okay, and just as a review, in section 9.1, we did 3 things. We did simplifying, we did multiplying, and we did dividing. Okay, those were the 3 things. Yeah, simplifying, multiplying, dividing. And we did that with things that were trapped and things that were not trapped. I'll put an NT. What am I talking about when I say like trapped stuff?
It's being multiplied, or
It's like when you have stuff like x plus 3 and x minus 6, and then you have like x plus 2 and x minus 6, right? I can cancel this and that, but I cannot cancel this x and this x because they are trapped together with the plus 3 and the minus, or and the plus 2, yeah? So my final answer would be that. That is just an example of simplifying, okay? What do we do when we're multiplying? So like I have some stuff and I'm multiplying it by some stuff. Same thing as what you were doing before, just multiply the tops across and the bottoms across and cancel what you can, right? If you are dividing, you keep flip, flip. Keep flip, flip, okay? Things that are not trapped would be like the x squared, y to the 3rd, z, and whatever else, x, y to the 7th, z to the 4th, right? Like those things are not trapped, so I can just cancel, cancel, cancel. Okay, by the way, just as review, what do we get? X's, where would the x go? X on top, 1x on top, right? Y's, 4 y's on the bottom, and z's, 3 z's on the bottom. Carson, watch, pay attention. That's what you would get. Those things are not trapped. You can just cancel, cancel, cancel all day long. That's a simplifying one. If it was multiplying, you would just multiply across like we just did, right? Okay, now, here is my question. When you're in elementary school, right, and they teach you something new, whether it's fractions or whole numbers or negative numbers, whatever, don't they teach you to add and subtract before you multiply and divide? Like, shouldn't that just be the way that it is, right? Didn't you learn to add and subtract before you multiplied and divide?
That would be correct.
So why are they having us multiply and divide in the last section, and now we're adding and subtracting?
because they want us to.
No, it doesn't have anything to do with PEMDAS. Let's talk about multiply and divide. So let's say I'm multiplying 1/2 times, I don't know, 2/3, right? 1/2 times 2/3. If I were to multiply those together for one thing, I could reduce the 2's, and those can become 1's, but then I just multiply the tops together, that's 1, and multiply the bottoms together, that is 3. So 1/3 is the answer. All right, now let's add and subtract. Let's say I have 1/2 plus 2/3.
You have to change the bottom.
Ah, isn't that make it more complicated? Finding a common denominator. Yuck. It's a lot nicer if I can just do this and find an answer, but here I have to do a common denominator. All right, what would your common denominator be with 2 and 3? 6. Okay, if I make this 6 and I make this bottom 6, what did you multiply by 2 to get 6? 3, so I have to multiply the top by 3. That's 3, yeah? What do you have to take times 3 to get 6? 2, so I have to multiply by 2, so this is 4. So if I add them together, it is 7 over 6 or 12?
Oh, 12.
13.
You're confusing me. 7 over 6.
7 over 6. You don't add the bottom numbers together, right? Yep. Like 1/3 plus 1/3 is 2/3, true?
Yep.
Not 2/6. You don't add the bottom numbers together, right? So when you are adding and subtracting, the reason why this is section 9.2 and not 9.1, you add and subtract after you multiply, divide, because adding and subtracting, you have to find a common denominator, which is kind of a gross thing, okay? They call it a least common denominator, or a lowest common denominator, okay? Let's go to example 1. I'm going to just jump right in. Are you ready?
Oh, yay.
Yes. Are you ready?
No.
Here we go. Oh, I don't like that they did this to you. That was not very nice. Whatever, it's fine. All right. Here are the 2 things that we're adding together. You see these 2 fractions?
Yeah.
Okay? We're adding this together. And what we need to do is, do we have room somewhere? Yeah, let's put it over here. Everybody rewrite it over here. 7a over 4b. Put it over here. I don't like their work, so I'm going to rewrite it. Plus, put this over off to the side. Everybody. Is it over 10?
Yeah.
10. Okay. All right. I'm going to show you how to do this. And every single time you're going to do it this way. And you're going to really pay attention to this first one because then you can get the hang of it and then you'll be good to go. Okay? You got the hang of it? Are we ready? You got it off to the side over there. Okay. I want to find my least common denominator. So 4b and 10. What number do you have to have in order for it to be 4b and 10 to go into?
20.
You could do 20. I like that idea. 20, but then it will also have to have b, right? So I'm going to make each piece 20b. Got it? Does 4b go into 20b? Yes. Does 10 go into 20b? Okay, so here's the deal. Here's what we're going to do next. What do you have to take times 4b to get 20b? I'm going to put times 5. If I have to multiply by 5, what would 7a then become on the top? 35a. Do you see how that works? No.
Hey.
Just 35a. I'm only multiplying by 5, right? To get from 4b to 20, I multiply by 5. 7a times 5 is 35a. Do you see that? Okay, now going from 10 to 20b, what do I have to multiply by? 2 and b. So I have to take 4c squared times 2b. 8c squared b, or bc squared, however you want to write it. Okay? All right? Do you see how that works?
Yeah, but now we're cannot.
But now what do we do now?
We're curve flunked.
We're curve flunked. Okay, sure. Here's what we do next. Do you see how we get those numbers on the top? Okay? Now, I just put it all under one roof, and I combine like terms if possible. Okay? So 20b, that's going to be my bottom, right? It's all 20b. Everything's the same. But can you add 3a plus ac squared b? Can you put those two together to make that like 43 something, something, something? No, not when you're adding. You have to have like terms. So I just write it as 35a plus 8c squared b. I cannot put those two together, so that is my final answer. Yeah? Finding a common denominator and then adding stuff together. Okay? Do you see how that works? Okay, let's go down and do part B. Here we go. I'm going to put it off to the side over here because I don't like their works. So 2x over 9y minus 7y over 6z. This is the top of page 500. The top of page 500. We're on part B. Top of page 500. I just rewrote them over here in the corner. Everybody find where we're at. Okay? What? Oh, no, you're right. 460. I thought it said 499. Shoot. Dang it. All right, so 460. Top of page 460, not 450, not 500. Okay? What? Don't worry about it. Don't worry about it. By the way, this thing that we're adding and subtracting, are these trapped or not trapped? Not trapped, okay? So let's, just so that we're all on the same brainwave here. Not trapped stuff, we're adding stuff together. But we still have to find common denominator. All right, everybody watch. Everybody watch. Are you watching? Everybody watch. This is what you need to do every single time you have a subtraction. Are you ready? Plus, minus. Do that for me, please. Anytime you're subtracting, change it to plus minus, because I have people that will do the adding and subtracting and they'll do their common denominators correctly and they'll do everything correct, and then they will accidentally put a plus sign because you're used to doing plus. If you change it in the very beginning and treat this as though it's -7, you will not forget the minus. So, I don't care. It'll be fine. Okay, so just change it to plus minus, all right? Do that really quick for me. All right, we have to find a common denominator. All right, so I have plus that stuff, all right? I need to take into consideration 9y and 6z. So let's just do number first. Give me a number that 9 and 16 go into. 18, right? Does 9 go into 18 and 6 go into 18? Yes. Okay, now, I just look and I say, I know I need to include y and I know I need to include z. So yz and yz, right? That's all you have to do. Does 9y go into 18yz? Does 6z go into 18yz? So we're good to go. All right? Do we see what we just did, finding a common denominator? All right, now I'm looking at my little thing here. What do you multiply by 9 to get 18? 2. What do you multiply by y and all this stuff to get yz? He needs a 2 and a z. True? To get from 9y to this stuff, I need a 2z. So let's multiply 2x times 2z. That will be 4xz. Do you see what we just did? Okay. Now, how do I get from 6z to 18yz? 3y. He'll need a 3 and a y. 6 times 3 is 18. And then I need a y from my yz. All right? Now take -7y times 3y.
-21y squared.
Negative 21y squared. Okay, we are so close to being done. We put it all under one roof. The bottom is 18yz because that's just the same. Can I add these two together? No, so I just do 4xz and then what? Minus 21y squared.
Oh, yeah.
Yep, plus minus just means minus 21y squared. Okay, good? Happy with that? Ish. Hold on.
Weren't you like just saying you're gonna mess up because you always put a plus sign, but then we just put a minus sign?
I'll show you why here in a second.
You got some double standards. going
Sure,
on.
I'll show you why here in a second though. Wait till we get to the trapped stuff. Then you'll forget to distribute a negative. You'll see here in a second why there's a method to my madness. Okay? Good? Good? Beautiful. All right. Here you go. Let's go to example 2.
Do you only have to minus the top or minus the
What? What?
You have to put the negative at the top or just the whole entire thing?
Just the top.
Good question.
Well, it's
So
like-
I put my negative on the top. If you would distribute a negative for both of them, what's a negative over a negative make?
Cancel.
A positive, so that's not making it negative. Does that make sense? You can either make the top negative or the bottom negative. Since I need my
Or both.
bottoms to match, I'm going to make the top
Or
negative.
you can
Make
just
sense?
Put it in the middle of them, and then the whole thing's negative.
Right, right. But then you
But
could
that's the
forget
way
to
you're doing it.
distribute a negative, right? Okay? All right, let's go down to example 2. Are we ready? Are we adding or subtracting?
Subtract.
Subtracting. So I'm going to do plus minus. Where do I have room somewhere? Let's put him down over here. I'm going to put him down at the bottom. Write this down at the bottom. 2x plus 1 over. Everybody write this down. Plus negative 7. Everybody write this down. Everybody write this down. Over here. I'm just copying him down so we can do our own work here because I don't like theirs. 5x minus 15. I did the plus minus thing. I'll write what they had. Plus minus. So they had minus, and I'm going to change him to plus minus. Okay, I'm going to make the 7 negative and put plus in between. So just recopy them over here and we'll do our own work stuff. Okay? All right. Trapped or not trapped?
Not trapped. Trapped.
This stuff is all trapped. These pluses are all together. It's like joining everything together. We have a mess.
Well, how do you know if it's trapped?
Okay? Trapped
Because of the
if
addition.
there's addition and subtraction that go on to like make stuff like gelled together. Like these guys up here, like I could cancel things, right? Like if it's just xy over x squared, y squared, right? Like I could cancel some of these and all that stuff, right? If there's pluses and minuses involved, I cannot cancel this x right here with an x on the top. It would have to be this whole piece cancels. Yeah? Okay, so trapped and not trapped, this stuff is trapped together. Like this is one whole chunk, this is one whole chunk. So when we have whole chunks, we break them down. Okay, we try our very best to break them down. 2x plus 1. He will not break down. There's nothing I can pull out. It's not a simple trinomial, a difference of squares. It's nothing. Okay, same thing with negative 7. There's nothing I can do to the top of that. But let's look at this bottom guy right here. X squared plus 2x minus 15. What is that?
X plus
He is
5
a
times X.
simple trinomial. So we multiply to get 15 and add to get 2.
X plus 5, X minus 3.
X plus 5, x minus 3. All of you guys are like shouting it all at once. That's awesome. X plus 5, x minus 3. Do you agree?
Diamond, quick.
5 times negative 3 is negative 15. 5 minus 3 is positive 2. So that will work. All right, what about 5x minus 15?
I got 5.
Yeah, that's a GCF, right? Greatest common factor. We're taking a 5 out, and left over is x minus 3. Okay, so I have it broken down like this. Got it? Woo! Okay, so we are now to like ready to start mode, right? This wasn't even like start mode. We are now ready to add them together.
So now
Okay?
we need to do something with the X.
Now we still need to find a common denominator though, okay? But this was like, you have to do some work before you can even start the problem, right? We've done that work, so now I can start the problem. Ugh. Okay, plus. I need to find my common denominator. All right, here's how you do this. Ready? I go through and I go list by list. I say, look at this x plus 5. He is so pretty. I need to have him in my bottom. And I need to have it in this bottom.
Well,
I know that x plus 5 has to be in my common denominator. Yeah? Okay. Then I go to the x minus 3 and I say, oh, look at how pretty that is. It needs to go in my common denominator as well. X minus 3. He needs to go in my common denominator also. So I'm going to include him. Okay?
but he needs to go 6.
Then I need to include a 5. So I'm going to put a 5 out front, and I'm going to put a 5 out front. He needs to be included as well, right? Like I need to have that in there. And then I look at this x minus 3. That's my last, the fourth piece. And I know I need an x minus 3 except.
You already have one.
I already have one.
So you just had.
So I don't need to add a second one because I already have him one. That's what's called the least common denominator. If I would do another x minus 3, that's just overkill. I don't need another one. True? Right?
Wouldn't it change the answer?
No, because mine will be in the most reduced form. It's like the difference between like your answer will be 4 over 6. Mine will be 2/3, right? It will be overkill, right? So you don't square it. You don't need a second one.
Just like the pen strength is overkill.
This
on that.
could be.
What?
So just like the pen strength was overkill on that 3. I couldn't even read.
Yeah, I know. It was hard, like, to write on here. I think I'll go down to 3. I'll go down to 2. How about that? Okay, so now, here's the deal.
You multiply it.
Ready? Before we move on, let's see if our common denominator is good. So I just look at this and I say x plus 5 and x minus 3. Will he fit into there? Does x minus 5 and x minus 3 fit into what I have? Yes. Cool. Does 5 and x minus 3 fit into what I have there? So I know I chose the right common denominator. I don't have any missing pieces, okay? Now, I'm going to start with 2x plus 1. That's my top, and negative 7 is my top here. Very good. What I'm going to do next is I'm going to multiply by the missing stuff. Like, what is he missing that he needs to have, right? Okay. So, what do I need to multiply this stuff by to get to this bottom here? Like x plus 5, x minus 3. He has an x plus 5, he has an x minus 3, but he's missing this 5, right? So, I'm going to multiply by 5. Yes? Okay, this one has a 5 and an x minus 3. What is he missing? He's missing an x plus 5. Yeah? Now we distribute stuff. Okay? All right, I'm going to answer Jace's question from a long ago here in this next step, right? If I have a 5 here, I'm just going to back distribute him, right? So this is 10x plus 5 on the top, and I have all my junk on the bottom, right? And I'm not going to rewrite it because I'm lazy. You see what I'm doing? Like my little squiggle is just the same thing from the top there. Okay, what about this guy? What will that be?
Negative 7x minus 30.
Jace, here's the answer to your question. You're like, that seems like overkill. Why would you change the plus to minus, blah, blah, blah. Okay, if I left this, hold on. If I left this as a minus and left that as 7, I would have 7x plus 35, and then when I went to distribute my negative, I would forget to do it to the 35. True?
How?
Because I would just be a dummy and I wouldn't do it, right? So I switch the plus to minus and whatever, I switch it first so I don't forget my signs are wrong here, right? Got it? And then I have all my junk on the bottom. Okay, now I combine into one roof. We're almost done. My bottom is still going to be 5x plus 5, x minus 3. Yeah? Okay, can I combine like terms on the top? Yeah, I sure can. What's 10x minus 7x? 3x. And what's 5 and negative 35? Minus 30. And is that my final answer? Done. Yeah. Can you what?
I was going to ask if you could divide, but I forgot that they're separated.
Can you divide?
Do the bottom.
Oh, right. So, like, technically, 3x minus 30 is 3 times x minus 10, right? Now, if by chance I would have like a 6 down here, I could reduce my 3 and my 6, and I could reduce x minus 10 if there was another x minus 10 there. So maybe look for that at the end just to make sure it's all the way reduced. But if he is all the way reduced, you don't necessarily have to break the 3x minus 30 down. You can just leave it that way. Got it? Make sense? Okay. Shall we do another? And then we're maybe snowed. Let's go here. Let's do number 1 together. And let's do number 7 together. Okay? 1 together, 7 together. And then I want you to do, what? Then I want you to do 2 and 4 and 12. 2 and 4 and 12 for now. Okay, let's do number 1 together and we'll do number 7 together. And then I want you to do 2, 4, 12 for homework. That's 3 problems. You can handle it. All right, everybody with me on number 1. Everybody with me on number 1. We need to find a common denominator, and my denominators are x and y. What's your common denominator going to be? XY, right? I need an X and I need a Y and I need an X and I need a Y. Yeah? Okay, what did you multiply by this X to get XY?
3y.
You need a Y, right? So this becomes 3Y. Do you see that? See how that works? Okay. All right, this Y became XY, so we need to multiply 5 by X. Okay, now last step. My bottom is XY. I'm putting it all under one roof. Can I add 3Y and 5X together? No, so what's it look like?
3y plus 5x.
That is all. Yep. You got it. Okay? Common denominator. That is all you're doing, right? That was number 1. Can we handle it? I think you can. You can do it. Okay? Now, that was not trapped stuff. Those were like X's and Y's just free floating around everywhere. 7 is all trapped things, which means we got to break stuff down. So I look at each piece. 3, I cannot be broken down. 2 cannot be broken down. W minus 3 cannot be broken down, but W squared minus 9 is? Yeah, he is a difference of squares. So real quick, I'm going to write out what the difference of squares is.
Is that it?
I take the square root. The square root of W squared is W plus 3 and W minus 3, right? That's how you break down a difference of squares. Good?
Leave that one.
So then you just
Oh,
put the
plus minus, by the way. Change your 2 to plus
then you put
plus
the
minus 2.
W plus 2, so you get 3
Okay?
W plus 9.
Hold on.
and then
Just
you-
wait a second.
three
Just wait a
W.
second. Just wait a second. All right, I've got 3 on the top. I've got negative 2 on the top. I got to multiply by what they need and multiply by what they need, right?
That one's
Okay, hold on. We got to find our common denominator first. Okay, so this guy we broke down as W plus 3, W minus 3. So when I do my common denominator, I go through. I have 3 pieces that I have to look at. W minus 3, I know I need him. W minus 3. I know I need W minus 3. So he is done. I go to the second piece. That's W plus 3. I need W plus 3. Okay, and I need W plus 3. And then I go to the third piece and I say, I need a W minus 3.
You already have it.
Oh, but wait. We already have one. Okay? So, does W, if I just check my denominators, whoop, whoop, does W minus 3 go into that? Does W plus 3, W minus 3 go into that? Yes, they both work, so we're good to go. Okay, now we just got to multiply what they need.
W
So,
plus
this
3.
one's W minus 3. He needs to be W minus 3, W plus 3. He's missing a W plus 3. By the way, if you want to check your answer in this step, W plus 3, W minus, or excuse me, W plus 3 and W plus 3, those would cancel out, right? And I would get back to 3 over W minus 3, which is what I had to begin with. So I'm not changing this thing. I'm just changing what he looks like by adding that, like what we were trying to get rid of in the last section. Does that make sense? I'm undoing it. All right, what is this guy missing?
Nothing.
He's missing
Big
nothing.
1.
So I can multiply him by 1, or you just don't have to multiply him by anything, right? Okay. All right, then we do the stuff and that stuff, all right? 3 times W is
3W.
3W. 3 times 3 is 9. Plus, this guy is negative 2. Can I add stuff together?
Yes.
Yep. 3W plus 7. And then the bottom is W minus 3, W plus 3.
Yep.
This is like a lot of steps and stuff. Yeah? If you don't write out lots of your steps, you're going to be super lost. Right? Brady?
I'm not lost. I've already done.
But you're going to make careless mistakes if you don't write out some work. You don't have to write out every single step that I'm doing.
Yeah.
But you're going to make
That's false.
silly mistakes.
They'll just get it.
Like when you were simplifying yesterday and you didn't do your stuff in your head right and then you got some wrong. And I was like, nope, that's not the right thing.
Right, but it-
Write some of it out.
But it didn't count wrong today.
Yeah, because I fixed it for you. It would have, because you would have just left it. So, write out some of your steps. Some of it I realize you can do in your head, but be careful. You only have 3 homework problems, and you have like literally 15 minutes, probably 20 minutes to get it done, okay? So, work thoroughly, do a good job, and then you will be done. 2, 4, 12. We'll add to that tomorrow. Got it? Page 463. I want to make sure you guys can do these well. That's why I'm not giving you a tons of homework, right? Thank you, Mrs. Comacher.
Thank you.
All right, 2, 4, 12. Do some good quality work. This is kind of intense, some of it, all right?
I go to the bathroom.
Okay,
I was gonna.
goodbye, people watching this video.